All right, we have a short lesson today, page 485 in your textbooks. We're going to move quickly through this as we begin reviewing for your final exam coming up in lesson 178. For you guys, that's Wednesday. Let's take a look at the homework as we get started. Page 485, numbers 1 through 13. There will be a whole page of equations for you to solve on this exam, and so we've been doing really well with those. That shouldn't be too big of a challenge for us, but let's just make sure we're good to go on these. Number 1, what did you get for your answer, Kirsten?
13.
13. Number 2, Jalen?
5.
5 is correct. You sound like me last week. Number 3, what did you get? Elaine?
-5.
-5. Number 4, Luciana?
10.
I'm sorry?
10.
Not 10. Corey?
-10.
-10. Yeah, careful on that one again. I think that those negatives just keep getting you there, Luciana. You got to get rid of the 11. I think you did by putting a positive 11 because I think you had a 20. But I just think you didn't divide by the -2. I think you only divided by 2, and that right there is where we get the -10 from. So you'll have equations like those on your test. Also, number 5 and 6. What kind of equations are 5 and 6? Bryson?
5 and 6, they're fractions.
Well, they are fractions equal to each other, but we call these...
Oh, proportion.
Not preparations, but you're really close. Griffin?
Proportion.
Proportions. Class, what do we call these?
Proportions.
Proportions. In class, we know that in any proportion, the product of the means equals the product of the extremes. And that's why, to solve a proportion, class, we should cross multiply. Now, when I look at number 5, just being honest with you, these are some big numbers. You know what I'm saying? But I told you this. I said a strategy tip. If you're working a proportion and you notice that one of those ratios can reduce, let's reduce it down. Let's make the numbers smaller. Bryson, how could I reduce a 15 over 20? By 5 to get 3 to 4. So we could say that 3 is to 4 as x is to 88. Now, there's nothing wrong with just straight up cross multiplying and saying 20x equals, Lord have mercy, whatever that...
1,320.
1,320, thank you. We could do that. There's nothing wrong with that, okay? It's just harder, and I'm lazy. I'd rather reduce it down and instead cross multiply 4 times x, class.
4x.
And well, 3 times 88 ain't exactly my favorite multiplication to do. It's still better than 15 times 88. And we get 264. From here then, either way, we either divide by the 20 or, better yet, divide by 2. Okay? Or divide here by the 4. Either way, we end up getting anyone? 66 is our answer. Again, that's your answer whether you reduced or not, okay? It's just the reducing gives you a little bit smaller numbers to work with. Number 6, there wasn't a reducing option there, Joel, but we cross multiply and we get what for our answer? 48. So you'll have proportions on that page of equations. You'll also have some equations like 7, 8, and 9. Now, what kind of equations are 7, 8, and 9, Michael? Starts with a Q. Quadratic equations. Very good. Class, what do we call those equations with x squared in them? Quadratic equations. And the key is that once you get the x squared by itself, how do we get rid of the little squared? How do I get rid of that exponent, class?
Square root.
Take the square root of both sides. Now, on number 7, the first thing we have to do, though, is get rid of that 8. And, Michael, what do I do to get rid of the 8?
Add a -8 to both sides.
Good, and that's going to give us x squared equals 81. And then I've got to take that square root. But when you take the square root of 81, there are actually 2 square roots of 81. X, of course, is the square root of x squared. The square and the square root cancel. But, Michael, what are the 2 square roots of 81?
Positive and negative 81. I mean, 9.
Positive and negative 9 is correct. So don't forget that little positive negative thing on number 7. Number 8, what do we have to do, Ben, to solve this quadratic equation?
Get rid of the 19.
Good, get rid of the negative 19 by putting
Positive 19.
on. And that's going to give us x squared equals 121.
1.
Good. And then, Ben, I got to,
2x.
no, I don't want, not 2x, I've got an x squared. How do I get rid of that little exponent? Class?
Square root.
Square root. What do I do, Ben, to get rid of the exponent?
Square root.
On
Both sides.
both sides. Now, the square root and the square are going to cancel, just like a positive negative 19, because they're opposites. Square and square root are opposites, they cancel, there's my x. But on the other side, then, we got to think back. What is the square root of 121?
11.
11. But I remember there are two square roots, so we'll say,
11 at 2.
class?
Positive.
Negative.
Positive and negative 11, technically. Both positive and negative 11 are two square roots. What about number 9? This one's got a little bit more going on in it. We got a 5x squared negative 3 equals 122. Let's come to Luciana for some redemption here. Luciana, what do we need to do here?
We gotta add positive 3 to both sides.
Because that's the least attached thing to the x, and that gives us,
125.
and then,
We're gonna divide 5x squared by 5.
good, divide the 5 away, but what we do to one side,
Divide it to the other side.
so we're going to divide the 125 by 5 as well to get x squared equals
25.
25. And then finally, now that it's just plain old x squared, I'm ready to knock off the exponent by taking the
Square root.
of
X squared and 25.
both sides to get.
X equals 5. Positive negative 5.
There we go, x equals positive negative 5. How many had that answer for number 9? There'd be a small section of quadratic equations on your final exam as well. So equations, a big part of that final exam. Word problems, also a big part of the final exam. So let's take a look at a few of them here in the homework. Number 10, read it for us if you would, Kirsten.
4 more than 2/3 of a number is 60. What is the number?
How many unknowns, Kirsten?
1.
Just one, and the one thing we got to figure out is
2/3 of a number.
the number. And so since I don't know the number, Kirsten, I can just call it
X.
x. But I got to go through and represent my equation. It says 4 more than 2/3 of a number is 60. What would that equation be?
2/3 x plus 4 equals 60.
Excellent. 4 more than means something plus 4. 2/3 of a number means 2/3 times a number. Well, the number's x because I don't know it. And when it says is 60 means equals 60. How many have that equation, first of all, for number 10? Excellent. Remember, the first part of every word problem is what's your equation. I don't care if you know the answer if you don't also know the equation as well. Now to solve it, Kirsten, 2 steps.
Put a negative 4 on both sides.
Good. And I wouldn't say it's wrong if you said subtract 4. Though I like it better if you say put a negative 4.
To get 56.
And then?
Multiply 3 over 2.
Good. To get rid of the 2/3 in one easy step, multiply the reciprocal. 3 halves, 3 over 2. And that cancels, of course, what we do on one side.
We have to do on the other.
So I'm going to multiply the other side by 3 over 2 as well, though it would help, Kirsten, if I put the 56 over 1. And if I do it, I can see that the 2 and 56 cancel.
28 and 1.
And then the 28 times 3, of course, the 1's in the bottom I can kind of ignore now.
84.
84. How many had 84 as your number? All right, questions on number 10. Yes, Sir Joel.
Will we be counted off if we accidentally put the positive 4 in the 2/3?
Like this, 4 plus 2/3 x. It's not wrong. I want you to get used to flipping it when you see the word than, but it's not wrong though. All right, good question. Good, number 11. Read that one for us if you would. Griffin.
Olivia is 16 years old than 16 years older than Patrick. If the sum of their ages is 54, how old is Patrick?
How many unknowns do we have here, Griffin?
2.
2, and they are?
Olivia and Patrick.
Are they actually both unknowns, or do they tell us one of their ages?
Both unknown.
They really are both unknowns here. Now, sometimes we work a problem and it says blah, 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 if Olivia is 24 years old, right? But it doesn't say that. We don't know how old either one of them is. So one of them has to be X, or whatever letter Griffin chooses. Which one is the X or whatever letter? Griffin?
Patrick.
Patrick. Because in the comparison, it comes back to Patrick. If we let Patrick be X, how would we show that Olivia is 16 years older?
X plus 16.
How many had Patrick as your variable, Olivia as the variable plus 16? Now, what's the equation then? We're going to use the number that ain't been used yet, Griffin.
2x plus 16 equals 54.
Good, if you add these together, the x plus 16 plus the x, you get 2x plus 16 equals 54. It said the sum of their ages is 54. We'll subtract the 16 from both sides to get 2x equals 38. We'll divide both sides by 2, Griffin, to get x equals... Anyone? 19. Which means, who is 19, class?
Patrick.
Patrick's 19. Olivia is considerably older. She's an adult. Of course, technically Patrick's a young adult here, but how old is Olivia, class?
35.
35 years old, and there's the sum of their ages. All right, questions on this? Questions. How many had 35 for Olivia, 19 for Patrick? Questions. All right, take a look at number 12. A little bit of an interesting problem here, Joel.
Andrew has 24 red marbles in a bag. The ratio of red marbles to blue marbles is 4 to 6. How many blue marbles are in the bag?
How many unknowns do we have?
1.
Really only one. There's two things mentioned, but there's really only one unknown, and that's the
Blue marbles.
blue marbles. We don't know the blue marbles. We could call it
X.
X. If you wanted to include the red marbles, you could, but it is actually known. It tells us there's how many red marbles? 24. And it says that the ratio of red marbles to blue marbles. Well, if there's 24 red marbles and there's X blue marbles, how would I show or write the ratio of red to blue?
24x.
Not 24X, ratio.
24 over x.
24 over X. How many see that the ratio of red to blue has to be 24 over X? But it says that that ratio, red to blue, is 4 to 6. In other words,
2 to 3.
it is 4 to 6. It, class, equals 4 to 6. Or, I like saying 2 to 3. I mean, why wouldn't you? It's easier. Smaller numbers. Big fan. Lazy. How many had 24 over X equals 4 over 6 or equals 2 over 3? 24 is to X is 2 over 3. And this time our equation, class, became a proportion because we have two different ratios. If we cross multiply, the product of the means here equals what?
2x.
And that equals the product of the extremes, anyone?
Yeah.
No.
72.
72. And if we divide both sides by 2, we do get our answer for X. How many blue marbles, class?
36.
36. How many have 36 blue marbles? Does it make sense how to set up that proportion? Question, Joel.
Can't you just can't you just pretend it's multiplied? You still get the same answer.
Oh, absolutely. Yeah, if you said times 12 and times 12, yep, nothing wrong with that at all. Good question, good. And hey, if you see a shortcut like that, by all means take it. It's not always there, but if it is there, I mean, why not? Good, other questions? Let's take a look at number 13. Read 13 for us, if you would, Jalen.
The perimeter of a rectangle is 20 inches. If the length is 2 inches longer than the width, what is the length of the rectangle?
What is the length of the who?
Rectangle.
Rectangle, there we go. All right, so how many unknowns do we have in the problem?
2.
2, and they are
Length and width.
length and width. And who gets to be X?
Width.
The width, because it says length is 2 inches longer than the width. So if we let the width be X, how would we show that the length is 2 inches longer?
W plus 2.
Okay, so you didn't call it X, you called it W, that's fine. So W plus 2. How many have the width as X or whatever variable, and the length as that variable plus 2? Now, we've seen a few of these by now. Perimeter, class, is not length plus width. So we won't say 2W plus 2 is the perimeter. Perimeter, class, has 2 lengths and 2 widths. So I've got to have, well, 2 widths and 2 lengths. Well, class, what is 2 times W?
2w.
And what is 2 times W plus 2?
2W plus 4.
2W plus 4, right? W plus 2 plus another W plus 2 be 2W plus 4. And so if I have 2 lengths and 2 widths, add that together to get your perimeter of 20 inches. What's our final equation going to be here, Jalen?
4W plus 4 equals 20.
Now, to be fair, if you're like, what is all this multiplying stuff? That's confusing, okay? Then say a length plus a width. So there's a length plus a width plus a length plus a width equals 20. You could do that, right? But you end up adding a W plus a W plus a W plus a W class equals, and you end up adding a 2 plus a 2, which is equals 20. So you get to the same point. It's just whatever you see better, right? Nothing wrong whatsoever with this. You do what's more intuitive for you. Questions on the setup before we get to the solving? All right, let's go ahead and solve then. We subtract the 4 from both sides to get 4W equals, anyone? 16. Careful, 20 minus 4 is 16. Divide both sides by 4 to get W equals?
4.
Which means that the W, or in other words, Jalen, the width is 4 inches. The length it said was 2 inches more. 6 inches. So what is the length of the rectangle class? 6 inches. Notice this time it didn't ask for the length and the width. It only asked Bryson for the length. So I only care about the 6-inch answer here. Questions on these word problems? Yes, sir.
If it only asked for the length, why'd you do the width?
Because you couldn't find it without finding the width. Right? The length was 2 more than the width, but unless I know what the width is, I don't know what to add 2 to. Does that make sense? For instance, if I knew that you were 3 inches taller than Brandon. Well, people watching on YouTube don't know how tall you are yet, but if I tell them how tall Brandon is, then they can figure out how tall you are. If they know Brandon is 5'11", well, now all of a sudden they know that you are 6'2". But without knowing that detail, they couldn't possibly figure out how tall you are. So even though I don't care about the width as far as the final answer, I didn't ask for it, without it, I couldn't have found the length. That's why I had to find them both. Does that make sense? Good. Other questions? All right, now one of the applications that we worked on last lesson for these quadratic equations, like we see in 7, 8, and 9, was using them to solve for right triangles. And we said a right triangle has how many sides, class? 3 of them. And all triangles do, but a right triangle is unique in that the right triangle has a right angle in it. And we said that the 2 sides that form the right angle are called what?
Legs.
They're called the legs. So this is a leg and this is a leg because they make up the right angle. But the side that's directly across from the right angle, class, is called the hypotenuse. Say that word again. Hypotenuse. All right, so great word. And we said we were going to represent these sides with different letters. First of all, the hypotenuse we represent, class, with the letter C. Now the legs, really doesn't matter which one you call which, but the legs we said we represent with the 2 letters A and B. We could call this A, for instance, and this B, or if you prefer this is B, that's A, really doesn't matter, but the legs are A and B. And there was a theorem, an equation, if you will, that described the relationship of these 3 sides. First of all, what's the actual equation with the letters A, B, and C in it that describes these 3 sides? Class? C squared equals A squared plus B squared. In other words, the hypotenuse squared equals one of the legs squared plus the other leg squared. What do we call this equation? That's a name. It's named after a Greek guy. Good. The Pythagorean Theorem. Plus, say that with me. Pythagorean Theorem. And we said if I know 2 sides of a right triangle and I want to find the 3rd side, it's as easy as just plugging in the numbers. So for instance, let's suppose that I know that one of these legs is 3 meters long. Let's suppose that I know that another leg here is 4 meters long. And the question is, how long is the hypotenuse? Well, we just plug it into the equation. Say the equation with me again, class. C squared equals A squared plus B squared. If I know a number, I plug it in for a particular letter. If I don't know a particular letter, I leave it as a letter. Well, which letter don't I know, class?
C.
I don't know C. I don't know the hypotenuse. So we're going to have to leave this side as simply C squared. But I do know A. A could be either, Corey, 3 meters or 4 meters. Doesn't really matter. You pick. 3 meters. That value needs to be squared. Well, whichever one he picked to be 3, the other one's got to be class 4. So we could say that c squared equals 3 squared plus 4 squared. Remember doing this on Friday. You're going to have a couple of problems like these on the final exam as well. From here, we simplify what we can. Can I simplify a c squared class? No, because I don't know what c is yet. Can I simplify a 3 squared class? Absolutely, it's 9. And then I can simplify a 4 squared, 16. Then we can simply add 9 plus 16.
25.
And if we know that c squared equals 25, to get c by itself, class, we take the square root. Now, normally when I take the square root, I would say positive, negative, whatever. But in the Pythagorean theorem, would it make logical sense to have a negative? No. So in that case, we'll ignore the negative. We'll just say class c equals 5. So therefore, the hypotenuse must be how long, class? 5 meters. Now that works out very nice and easy, but sometimes the numbers don't work out as well. The students in the room have those handouts from the last lesson. So if you're watching on YouTube, go back to the last lesson very quickly. There is a table of squares and square roots handout that you'll want here. But let's suppose that the right triangle, class, here is my chalkboard. But let's suppose that I were to, and I'm too lazy to do it, draw a line from the bottom corner of the chalkboard all the way to that top corner. We call it a diagonal. But do you realize if I were to draw this diagonal, it would make a right triangle, where the right angle is down here in this corner. Do we see it? Well, the chalkboard is 12, let me kind of show it this way. Here's the chalkboard, 12 feet across the bottom of the chalkboard. And it's 4 feet up the side of the chalkboard. The question is, if I were to draw that diagonal line, how long would it be? At your seats, solve. And use the chart to get your approximate answer, because it's not going to come out evenly this time. How long would be a diagonal drawn from one corner to the opposite corner of the chalkboard? If I weren't too lazy to draw it, how long would it be? What do we write down first, Ben?
C squared equals 4
4 squared.
plus 12 squared,
There we go. And what is 4 squared, Ben?
16,
And 12 squared?
and 44,
And when we add 16 plus 144, we get,
170,
oh, careful, not 170. Should be 160. And then we have to take the square root of both sides. And unfortunately, you can't take the square of 160 evenly. But if you look at the chart, class, what is the square root of 160, approximately? 12.619. Okay, so approximately, and this isn't exact, but approximately 12.62 feet. Approximately, roughly that. Yes, ma'am.
C was 12.649.
49. I'm deaf, I can't hear. So then in that case, we'd say about 12.65 feet. All right, we like 12.649 a little bit better? Speak so I can hear you. How about that? All right, now this is easy if you're finding the hypotenuse. But you realize you don't always know the two legs. Sometimes you might be finding one of the legs. For instance, let's suppose that I already knew the hypotenuse was 21 inches long. This actually looks like it might be about 21 inches. Let's suppose I knew that this baseline was a foot, 12 inches long, and I wanted to know how tall my right triangle is. Well, in this case, class, I don't need to find C. I already know C. I need to find either A or B, and we'll let Michael pick.
B.
So if we call this B, then that makes this A, and of course this class is
C.
C. So what do I write down first, Michael?
21 squared equals 12 squared plus B squared.
And from the chart, we can look at 21 squared, class.
441.
441. We already know 12 squared, class.
144.
144 plus the B squared. And what do we have to do next to get that B squared by itself, Elaine?
Cancel the square root.
Nope. I want to get the B squared alone.
Subtract.
I have to subtract what?
B squared.
No, I don't want to get rid of B squared. I want to get rid of what's with B squared. Who's in the same room with B squared?
Exponent.
Well, the square is a problem as well, but there's something that's less attached to the B squared.
The 1.
Class? 144 right here. Do you see it? Here's the equal side. It's in the same room. I got to get rid of this 144. How do I do that?
Subtract 144.
There we go. From both sides, we're going to subtract that 144. Now the B squared is by itself, so we'll be able to take the square root in the next step. 441 minus 144. What is that? 297. Then I got to take the square root of both sides, and 297 is not on the list.
Man.
Is there a number around 297 somewhere in the square column?
3.
It's 289.
There's a 289, and 289's square root would be 17, right? And the next number after 289 is 324, whose square root is 18. In this case, we kind of have to guess. And you won't have to do this on the test. We're just showing this as an example. But we know 297's square root is going to be between these. Which one will it be closer to, class? It'll be really close to 17. Maybe something like 17.2-ish. So I know that this line here would be somewhere around maybe 17.2 inches. Let me give you one that the numbers work out just a little bit better. Let's suppose I have a really tall, skinny right triangle. Suppose I know the hypotenuse is 37 centimeters, and suppose I know that this leg here is 35 centimeters. And I want to know how long the bottom leg is. At your seats. Bryson, what should I write down?
The 1,000
Well, let's start by saying 37 squared.
equals 35 squared plus B squared.
All right, and then when we look at the chart to figure out what 37 squared is, because we're lazy,
1,369.
and then the 35 squared.
1,225.
All right, Elaine, what do we have to do to get the B squared by itself?
We have to subtract 1,225 from both sides.
And when I do, I'm going to get B squared equals what, class?
144.
Oh, that's not so bad. Now I can take the square root of both sides, and we end up getting that this little baseline here, class, would have to be 12 centimeters in this particular problem. 12 centimeters, the length of that particular side there. Questions on the Pythagorean theorem? All right, now that'll be on the exam. There'll be some other things. Go and pass those square and square root tables forward, if you would, please, to the front of each row. I'll go and collect those from you. But there's some other things we talked about. For instance, tomorrow we'll be reviewing a lot of different things. We'll be reviewing area, perimeter, surface area, volume, measures, probability, statistics, graphs, all kinds of fun things. Well, let's park on graphs for just a second. You're not going to have to actually do any graphs. But you do need to know the different types of graphs and what they're used for. For instance, if we wanted to draw a graph that compares parts to the whole, class? Circle graph. If we wanted to draw a graph that shows changes over time, line graph in general. Could be broken, could be continuous, could be straight. If we wanted to compare related but independent data. If we wanted to group data into classes and then compare the classes to each other. Histogram. Or show frequency within groups is another way that one's been described. If we wanted to compare groups within bar graphs. Stacked bar graph. Now a stacked bar graph uses different colors in each bar, and we have to know what the colors mean, so we have a little color key off to the side called a legend. At the top of every graph we should have the chart title that tells us what the graph is about. The numbers that help us to read the graph are called the scale, and the words on the side that tell us what everything is the labels. The lines that help us to read a line graph and bar graph are called well, in general, just grid lines. The ones that have numbers next to them, the major grid lines, and the little ones that help us to get more detail, but they're not numbered, the minor grid lines. So there was some stuff, remember, with graphing that we talked about. I think those are all the graphs we did, right? Histogram, bar graph, stacked bar graph, line graph, circle graph. I think that was it for the graphs. We skipped over a couple different types of graphs that we'll talk about later on. With statistics, remember, we said that we could find 3 M words, measures of center, right? The average is called the mean. The middle value is the median. But that's only true if the numbers are put in order numerically, right? What do we call putting them in numerical order? That's called ranking the data. If we rank it, we can find that middle value. And then the number that occurs most often is called the mode. If we wanted to get an idea of how spread out the data is, one way is to look at the difference between the lowest number and the highest number. Class, that's called the range. So we talked about that. We talked about the likelihood of some particular thing happening, which, by the way, the likelihood of my Pacers winning an NBA title just went up. Now, it's still not real likely. People are still saying it's 0 because they don't think we can get past the Celtics. But we are now one of only 4 teams left. So our odds, statistically speaking, went up. But the odds of something happening, class, or the likelihood that something occurs is called probability. And in general, to find probability, we would compare the number of desired outcomes to the number of total outcomes. For the Pacers, the only desired outcome I have is Pacers win NBA title. That is one desired outcome. But there's only 4 teams left now. There's no longer 30 teams that could win it all. There's only 4. So the odds of the Pacers being that team, theoretically now, is 1 to 4. 1 to 4 probability. What about if we talked about the probability something does not occur? That's called the complement. The complement, remember, is the probability. So what's the probability of the Pacers? Again, this is theoretically, but the probability of the Pacers don't win the title. 3 to 4. Because if there's a 1 to 4 chance we do win, that means there's 3 of other teams that could win. 3 to 4 chance we don't. Now, what is the probability of an impossible event? 0. And that's what y'all keep telling me is the probability that the Pacers win the NBA title. What is the probability of something that is certain or definite? 1. And all probabilities have to lie somewhere between 0 and 1. If I wanted the probability of either this or that happening, what would I do with these 2 probabilities? Add. When you talk about probability of this or that, we're going to add. What about the probability of this happening and then something else happening? We're going to have to multiply those probabilities together. We're going to be reviewing a lot of that stuff tomorrow. Now, problem is, I mentioned a couple key things that got some scared looks, like area, surface area, volume, and measures. Flip over in your books to page 524. Flip to page 524 in your textbooks. Page 524. Do you see there's a reference section here with a whole bunch of formulas on it? I'm going to have you copy, not the probability formulas, but you're going to copy the rest of the formulas on this page for homework tonight. Look across the page. Look at page 525. Do you see this section down here which is called measurements? I'm going to let you skip the metric prefix meanings. We'll review that in our own way tomorrow, but I do want you to copy these other things, just one time each, for homework this evening. So you're not actually doing any math for homework, you're simply copying perimeter, circumference, area, surface area, lateral surface area, volume formulas. You're copying all of that tonight, and you're copying your U.S. customary measures of length, weight, capacity, and then all the measures of time. You're copying those just once on paper for homework this evening. Your exam will be in lesson 178 tomorrow. I'll take a look at that homework, and then the review tomorrow will include that stuff. So as you're doing the homework, it'll help you be better prepared, obviously for the exam, but also for tomorrow's review. Have a wonderful rest of your day. You are dismissed.
Sorry.